All right, let's take a look at solving some absolute value inequalities. There are two cases here. If the absolute value of x, and it could be, just an x, it could be a binomial, but as long as your absolute value is less than a, it becomes we drop the absolute value bars, and it becomes x is less than a, but also greater than negative a. So put x in between your less than symbols, negative a on the left, positive a on the right. The other the other case is if the absolute value of x is greater than a, in this case greater than or equal. It doesn't matter if there are lines under the symbols or not. Treat it the same way. So if it's the absolute value of x is greater than or equal to a, then it will become, drop the absolute value bars, and it's x is greater than a. But then on the other side, what gives us the negative side is switch the sign and a becomes negative. So again, if it's the absolute value of x greater than or equal to a, here is x is greater than or equal to a. That's going to be the positive side of the number line. And then the second part of this case is to switch the sign and a becomes negative. And so this will be the kind of negative side of our number line. So we use the symbol of this big capital U for unioned with. You'll have usually like a couple of endpoints here. And so it will be negative infinity to what we get as our endpoint on the left side, unioned with how we open towards infinity on the right side. So we'll take a look at a couple of examples. For number one here, the absolute value of x plus 9 is greater or is less than 12. So this is case one. These are probably easier to work out. We just put the x plus 9 between our less than symbols. Positive 12 over here, negative 12 on the left. And then you just get x by itself. So negative 17 on the left is less than x is less than 3. Oh, sorry, negative 21. Negative 12 minus 9 is negative 21. So no line underneath the symbol means that we go from negative 21 to 3 on the number line. So that's if it's the absolute value is less than, then just put your absolute value piece, drop the bars, put it between two less than symbols, and solve. Let's look at a greater than example, number 2 here. So I think about it like this. We have the x minus 7 is greater than 6. That's really just what it says in the problem. We just drop the bars, but that's going to be on the right side. That will give us the positive side of our number line. We also have x minus 7, and then I switch my sign, and it's negative 6. So again, in a greater than problem, kind of how it looks, that'll give us the right side of the number line. And then the left side of the number line will come from switching the symbol and making a negative. Whatever your value on the other side of the symbol is, change the sign. So the math is easy. It's just we have to know how to set it up. Add 7 to both sides. So we get 1 over here. add 7 to both sides, and we get x is greater than 13. So I set it up like this because now this is opening up towards the left side of the number line. And what we worked out over here, basically what the inequality statement says, just drop the bars, that will give us the right side. So on a number line, x is less than 1, we would have an open point or a parenthesis at 1, and we would shade towards a negative infinity. So our interval notation, well, we'll get to that in a second, because let's do the right side of our number line. X is greater than 13, we would put a parenthesis here and shade towards positive infinity. So the solution to this problem lies in this region on the number line, from negative infinity to 1, unioned with 13 to infinity. So that's how you write the answer. So the greater than problems are trickier, so we'll look at one more example. If you want to pause and take a look at number 6 here. The absolute value has to be isolated, so we add 16 to both sides, so that the absolute value of 5x plus 10 is greater than or equal to 35. And now again, move this down. We're going to split this up into 2 pieces. Drop the bars. And we have 5x plus 10 is greater than or equal to 35. Basically what the inequality says. I put this on the right because this will give us the right side of the number line. On the left side is 5x plus 10. And then I switch my symbol. And instead of positive 35, we change the sign to negative 35. And now we just solve this. So we get 5x is less than or equal to negative 45. Divide by 5. I'll go down here. X is less than or equal to negative 9. So it's x is less than a value, so it's going to shade towards a negative infinity. Over here, we'll subtract the 10, so that 5x is greater than or equal to 25. Divide the 5, so that x is greater than or equal to positive 5. So these are the 2 inequality pieces here, but we need to put it together in interval notation. If you can do that without the number line, that's okay. But we go from negative to positive infinity. First, we stop at negative 9 for our first region. And then we pick back up at 5 with a parenthesis. No brackets here, because there's a line under the symbol. So our answer is the interval notation is that we go from negative infinity to negative 9, unioned with 5 to infinity, using brackets around the values and parentheses at the infinities. So let me know if you have any questions, and I hope that helps.